Hi there. I guess you are ready to learn again something about waves. And this time we're going to talk about the light waves. For all we know that light is an electromagnetic wave because even in a vacuum it can travel. And as well as it moves perpendicular to the direction of the wave, the reason why it is also an example of a transverse wave. So therefore, there is a question that how are we going to see the different colors of white light? To make it simple, with the use of a prism, the angle of refraction is different from this color as they have different wavelength. So as the white light strikes on the prism, it creates, or because of its how the light bends, it produce different colors, and those colors are called the spectrum. So we have to demonstrate this existence of these colors, components of visible light using a prism and discuss visible light and enumerate the different source of light and their characteristic. So let's begin with what we perceive or what the eye perceive, and that is called the visible light. Visible light in the form of white light produces 7 colors. Like in the first picture that you see or you saw, that's the rainbow, composed of red, orange, yellow, green, blue, indigo, and violet. Those 7 colors are the spectrum. So Isaac Newton was the first one who reported this incident more than 300 years ago. Aside from that, in that principle, the original beam of white light could be recovered by passing the spectrum through a second prism to recombine the colored beams. The color of the beam light is determined by its frequency, or equivalently, it's the wavelength. We can say that in 1 second, the frequency or the number of waves tells something about the frequency of that wave. Higher frequency creating short distances between crest to crest or short wavelengths, while low frequency create less number of waves that pass in 1 second. Our eyes react differently to varying electromagnetic waves and perceive these different frequencies as different colors. Red light has the frequency that roughly corresponds to the wavelength of the violet light. So what does it mean? At the other end of visible range, it has nearly doubled the frequency and just over half the wavelength. The other colors we see have frequencies and wavelengths intermediate between these two extremes, like the orange, yellow, green, blue, indigo. Nanometer is the unit used to describe the wavelength of the light, and angstrom, the other unit used. In the visible spectrum, the wavelength ranges only from 400 to 700 nanometer, or 4,000 to 7,000 angstrom. These are the different light waves, from low frequency waves such as radio waves, microwaves, infrared, to the high frequency waves such as the ultraviolet, X-rays, and gamma rays. The only light that can be perceived by the eye is called the visible light. It is a white light that has different wavelengths for the different color. So then again, we can only perceive 400 to 700 nanometer. Human eyes are most sensitive to radiation, which has a wavelength near the middle of this range. So that is about 550 nanometer, and that is the green color, yellow-green color. I want you to notice or look at this wave or waves, and then from low frequency light waves to high frequency light waves. At the middle, we have the visible light that compose of different spectrum. Based on their size, you may describe that the wave of the radio wave is the same with the buildings, while the microwave is same with the grains of sugar. Infrared is same with the protozoans or microorganisms. Visible light for bacteria. Ultraviolet, size of the molecules. X-ray, size of the atom. And gamma ray, the atomic nuclei. So both radio and infrared are located in low frequency, like what I told you. Long wavelength side of visible light. These frequencies include the radar, the microwave, radiation, and the familiar AM, FM, and TV bands. Infrared is perceived as heat. Ultraviolet, X-ray, and gamma ray radiation are located at the high frequency. They have short wavelength side of visible light. The ultraviolet radiation found just beyond the violet end of the visible spectrum is responsible for suntans and sunburns. While X-rays are best known for the ability to penetrate human tissue and reveal the state of our insides without resorting to surgery. And last, the gamma rays are the shortest wavelength radiation. They are often associated with radioactivity and are invariably damaging to any living cells they encounter. So that's it for our review this day about this light and the spectrum. See you again on the next review. Goodbye.